So we're getting really close to doing some real work with Spark. But one fundamental that I've missed so far, and you definitely need because it's so important, is what a flat map is. In this chapter, I'll be showing you flat maps, and also we'll have a look at how to do filters. You'll be familiar by now with the concept of running a map transformation in Apache Spark. Given an RDD, we can run a map which will take a function and apply that function to every value in the RDD. And what we're going to get is a new RDD based on the results of that mapping function. But we've also seen that there is a restriction with map. There must be one output value for every single input value. This is the square roots example that we used a long time ago now. For every value in the input RDD, there will be a single value in the output RDD. But there are some circumstances where this isn't going to be the case, and you need, as a result of a single input value, you need multiple outputs, or possibly even no outputs. And that's where a flat map comes in. By way of an example, imagine that we have an input RDD here which contains a series of strings. The strings are sentences. So the first element here, for example, is a sentence containing 4 words. The second element here is the gap. This is just an empty string. And then we have a final string which appears to contain 3 words. A very common requirement is to split this RDD so that it contains just single words. How can we do that? Well, a map would not work here because clearly for this first line, we're going to want to see 4 elements in our new transformed RDD. So we're going to want to apply some kind of a function which is going to split that string into, in this example, 4 new strings. Now this second line, as I say, is just a blank string. So in this case, the same function, when we apply that to this second string, is going to return, well, just emptiness. There won't be any strings output as a result of that function. And then we'll be applying the same mapping function to the third line, which should generate 3 further strings. So as I've said, this is a job for the so-called flat map function. And flat maps are very common in functional programming, and the term flat map does tend to cause a lot of confusion because it sounds, well, I don't know about you, but to me it sounds quite sophisticated and it sounds like it's doing something really scary. But actually a flat map is doing nothing more than you can see here. Given a single input value, 0 or more output values are going to be the result. Now it's called flat map simply because what will happen is Spark, in this case, once it's done the map, will have multiple values which it will then flatten. And the flat part just means, in this case, it's going to create, in Spark's case, it's going to create an RDD with the values just in a single flat collection, exactly as we've been used to seeing. So the method we're looking for in Spark then is called flat map. Now back into our workspace, so previously we were counting up the warnings, the errors and the fatals. But I suggest now we change the example so that we're going to split up this input data into individual words that appear in our logs. So I suggest then we delete the work we've done before. So we've got our Spark context and we've got the Spark context.close. So as before, we're going to parallelize the input data. And that will give us our raw Java RDD containing strings, each of which will be sentences. I'll need to import Java RDD, and that's looking good. So we can take the sentences RDD then, we can apply our new flat map function. So as usual, in the map, we're going to be given a value, which will be an individual element of this RDD, So in this case it will be something like this string here. Now we've got to do some processing to this value to split it up into individual strings. So you might think at first it's a simple case of doing something like value.split, and as usual, standard Java, we can specify, to keep things simple, we'll just use a space as the split point, and that will split this value into multiple strings. But as you're going to see, this isn't going to compile. And the reason it isn't going to compile is simply due to the contract of the FlatMap method in Spark. We really need to look at the API or the documentation of Spark to understand exactly what's going on here. Now perhaps the compile error here might give you a clue. It's saying it cannot convert from a string array to an iterator. Now let's handle the string array first. You might remember that when you call split on a string, it does not produce a Java collection. It's a raw string array. I can confirm that. I'm here in the standard Java docs for Java 8, and this is the string class. The split method here, the return type is string array. Now it turns out that what we need is a collection, a regular Java collection here, and not an array. And unfortunately, as far as I know, if you look up and down the Java docs of string, you're going to find that there isn't any method. There's no methods in here that return a collection, such as a list. But this is just standard Java really, and a very common trick is you can use a convenience method inside a class called arrays. You might be aware that inside that class there's a method called asList. And if you pass into asList an array, in this case an array of strings, then it will convert that into a regular list of strings. So I hope that's okay. I'm rushing that a little bit just because it's standard Java, and if you weren't aware of that, you could have found that out very, very easily on Stack Overflow. You would have just looked for how do I convert a string array into a list. Now we still have a compile error. Now this is slightly annoying again. It's just one of the quirks of the Spark API. The list is actually fine, but the API specifically demands that you return an object of type iterator. I won't get hung up on this. I don't know how much you know about iterators, but in Java, every single collection has a method on it called iterator, which will return an iterator. And that's exactly what this API is looking for. So given that we've created a list here, which is a standard Java collection, we can simply now call .iterator, which will return an iterator of type string, which is exactly what FlatMap is looking for. So with FlatMap then, we have a function of some kind which is going to return an iterator, which is going to return the values that we want to be part of our new transformed RDD. I hope you've got at least a reasonable feeling for it, but just to return to the caption, what we've done with that function is we've written a function that given any one of these values in this RDD, such as this one, we've written a function which will provide an iterator which is going to give Spark a series of values, and there can be 0, there can be thousands of values as a result of that iterator. Now that we're there, it's not too bad because we've ended up now with a new Java RDD of type string, and this is going to be containing individual words. We'll do our usual routine of on our final RDD, we'll call the forEach method and pass in the method reference of system.out : println, just as a test, just to see if the end result is what we expect. And yes, well, they're not words exactly, but they are the individual elements of the input sentences from those logging lines. FlatMap is so important, you're going to be using it endlessly if you're working in Spark. So I hope that's a good introduction to it. We'll certainly be using it again in the future.